Gotta catch 'em all, Pokemon. Hey, what's up, y'all? Hamad's back in the house. So today we're going to be talking about what isotopes are and what ions are, okay? First, let's go to isotopes. So isotopes, that is when the atoms of a single element have this, well, of course, since they're the same element, they all have the same number of protons. However, they have a different number of neutrons. This difference in the number of neutrons often usually results in what the most noticeable thing you see with the different number of neutrons is a different mass. So I've talked about in previous videos how I've said carbon 12 and carbon 13. These are both isotopes of the element carbon, okay? However, this has the same number of protons and neutrons, which is 6 protons and 6 neutrons. And this carbon right here, it has 6 protons because it's of the element carbon, and 7 neutrons because the total atomic mass was 13 AMUs. 13 AMU for this carbon atom, and 12 AMU for this one. 6 plus 6 equals 12, which gives you 6 protons, 6 neutrons gives you 12. It gives you about the total atomic mass of this carbon atom, and this gives you this. So when you see the word isotopes, that just means that it's an atom with a different number of neutrons for that element. Let's move on to ions. So ions, this is when an atom has a charge. Previously, when I've talked about atom, they were all so and so neutral. Neutral meaning it has no charge. However, when an atom does have a charge, hence the name ion, that is when it has an imbalance in the number of protons versus the number of electrons. In all of the past examples I've used, for the most part, the number of protons and the number of electrons were equal in all the atoms. So I keep on using carbon, but let's say we had an example for let's say the element let me see, I want to use a different element. Screw it, let's use carbon, screw it. So carbon, no, that's for calcium. Carbon, it has a total number of, oh man, I'm sorry. Hold up. Carbon atom number. Okay, so it has, I had to search it up on my laptop real quick. So carbon, it's atomic number 6, so we know it has 6 protons. And in a neutral carbon atom, it would also have 6 electrons. However, if we had a carbon ion, it could be, we could write it as carbon, let's say it also has 6 neutrons, to keep it simple. So carbon 12, and carbon 12 minus. So this minus represents a charge. You could also say 1 minus. It represents a 1 minus charge. So that means this would have 6 protons due to it being carbon, 6 neutrons, since its atomic mass was 12. However, it would have 7 electrons. Now, whether this actually happens in real life or not, I mean, okay, in life, carbon won't usually make ions. It will usually make something called a covalent bond with other atoms, and we'll talk about that later, but that was my fault. Let me use a better example. Of an element. So a better example would be let's see, potassium. Okay, so potassium, this is potassium, atomic number is this, and it has 39 point something, something, something. That's what potassium looks like, okay? So potassium K plus, and then since atomic number is 19, let's just round it off to let's say it's 38. Okay, so we know it has 19 protons since it's potassium. It has 19 neutrons since its atomic mass is 38. 19 plus 19 equals 38. However, since it has a plus, it has 18 electrons. This is because there's one more proton than there are electrons, giving it a +1 charge, a +1 charge. So electrons give you a negative charge and protons give you a positive charge. Okay? So let's go through some sample problems and whatnot. So if we were given, let's say that an isotope has 16 protons, 18 electrons, and 16 neutrons. And the question is asking us what element it is and how to write it. So since it has 16 protons, if we go to a periodic table, we go to it, and the element with 16 as its atomic number will be the one we're talking about. So we go and we find that it's sulfur, S, okay? We add 16 plus 16, which gives you 32, which is the atomic mass, and then the charge. If we have 16 protons and 18 electrons, that will give us a -2 charge. The way we write the negative charge is if there's more than one, is you write the number first, then the sign. And we do that so we don't get it confused with exponents and stuff. So this would be the answer for this question. And sorry, I didn't mean to say isotope before. I just meant to say just a normal one. Actually, no, you could say isotope. This is that specific one. Never mind. Disregard what I just said. So let's say we were given this, and it wants us to give us, and the question is asking us number of protons, number of neutrons, the number of electrons. That's an abbreviated version for electrons. These I don't know. So since it's fluorine, if we go to our periodic table, the number of protons would be, no, since it's fluorine, the number of protons would be 9. Okay, so the atomic number of fluorine is 9. And 9 protons. And we have an atomic mass of 18, so if we subtract 9 from 18, we will be left with 9, which means we now know that we have 9 neutrons. Lastly, it has a -1 charge. So if we have 9 protons, that means we need to have a greater number of electrons than there are protons. Therefore, we would have 10 electrons. Okay? And lastly, just for vocabulary and stuff, when you see a cation, it means a positively charged ion, and an anion is a negatively charged ion. And remember, an ion is when an atom has an imbalance in the number of protons and electrons, meaning it will have a charge. And an isotope is when atoms of the same element have a different number of neutrons, resulting in a different mass. Thank you.